I've talked about how we can try and use this interference pattern with a double slit to measure the wavelength of light with this formula. Right, where lambda here is the wavelength, x here is the spacing between the slits. I've also talked about how we can make the fringes narrower by using more slits. Now the next thing I want to do is to get a better formula where I don't have this approximation here to make it more accurate. But before that, let me say describe more about the setup in which there are more slits. Now this this setup or device is called a diffraction grating. Diffraction grating is something you can actually buy commercially. It looks very much like a small piece of glass. Right? It doesn't really look any different, except that when you look at it, it would look quite shiny and colorful because of the way it transmits and reflects light. Now, on this little piece of glass, there would be many lines. These are very tiny lines that are drawn on the glass using special methods. So each of these lines can block some light, and in between the lines, the light would be able to pass through. Now we are talking about a piece of glass which is typically maybe about 10. It is a square of about 10 to 50 millimeter size. So maybe 10 by 10 or 50 by 50 millimeter, or somewhere in between. So that's the size that we're talking about. And there are lots of these lines. Now, exactly how many? Well, a typical number would be, let me just clarify this number to avoid confusion. Size of that number there refers to the typical size of this piece of glass or diffraction grating. Now, the number of lines that are drawn here, which in fact would be the number of slits, is typically 10 or let me use millimeter. It's typically 1,000 lines. Can be more, can be less. 1,000 lines per millimeter. Now that means that if we think about, say, a distance of 1 millimeter in this direction, 1 millimeter. So in this distance of 1 millimeter, there would be 1,000 lines. So they're very closely spaced. We're talking about we are talking about a spacing between slits of 1 millimeter divided by 1,000. Okay, let's work this out. The slit spacing, that's what I called A in my previous session. Okay, 1 millimeter, 1,000 lines. So it will be 1 millimeter divided by 1,000. So we are talking about 1 micrometer. So they're that close together. Suppose that I have a green light coming through the spacing. So there'll be diffraction. The green light will spread out. The green light doesn't have to be just one ray. It can be right, a beam of green light falling on it. So the green light will spread out, and on a screen some distance away, I will get the fringes. So there could be a green spot here, a green spot some distance away, above and below, right, and maybe more green spots further away. Okay, and we can actually then measure the spacing between these green spots, and that would be x. That would be the distance x that I described in for the double slit experiment. Okay, so in principle we can then use the formula, let's see, lambda over a is approximately x over d, to find the wavelength of the lights. Since we would know a, this would be given by the manufacturer when we buy a diffraction grating from them, and d would be the distance. Okay, so d would be this distance from grating to the screen. So that's how we could do it. But as I said, I want to get a better formula without the approximation. So I'll explain how to do that in the next video.